Today's lesson is titled Coordinate Plane Congruent Triangles, and what we're going to be doing is learning how to prove triangles congruent or determine if they are congruent when our triangles are in a coordinate plane, meaning they're on our x and y axes. Okay, so let's take a look. Problem number 1 says prove the two triangles are congruent. So we see this diagram, and in it we have triangle ABC and triangle ABD. So I'm going to go ahead and outline triangle ABC in a green marker, and I'll outline ABD in a blue marker so we can see the difference. Remember, we have to name them in the correct order. Okay, so if I start on A, going up to B, and then over C, and vice versa. Now, if you notice, I highlighted one side in both colors, side AB. So they do share a common side. So based upon what we know, we don't know anything about the angle measures. Right now, we don't know anything about the side lengths, but we do know we're on a coordinate plane, and we do know how to find the length of a side of a line. We learned that in Unit 1. So let's go ahead and let's find the side lengths, because I really don't have any information to help me figure out the angle measures. So let's start with line AB. Now AB is a vertical line, so I don't have to draw my triangle step. I can just count boxes. 1, 2, 3, 4. So the length of AB is 4 in both triangles. Good. All right, let's take a look at AC. So I can go from A, draw a line over, draw a line up to C, and I'll count my side lengths. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and if you remember back to how to find length, we're going to use the Pythagorean theorem to find the side. Okay, so I have 6 squared plus 6 squared is equal to AC squared. And when I do my math, I get 36 plus 36 equals AC squared. When I add them together, I get 72, and then I have to take the square root of both sides. So it's the square root of 72. So I'll go ahead and write that over here. All right, let's find the length of AB. So once again, drawing a slope step from A to D. And I count 1, 2, 3, 4, 5, 6. And I count 1, 2, 3, 4, 5, 6. All right, well, I see that it's the same numbers from that I saw in my first triangle. Okay, we would use Pythagorean theorem again. 6 squared plus 6 squared equals AD squared. Well, since I know that what the math is already going to work out to because the sides are the same length, I know it's going to be the square root of 72. All right, let's move on to BC and BD. So BC is right here. I have 1, 2. 1, 2, 3, 4, 5, 6. So if I use my Pythagorean theorem, I have 2 squared plus 6 squared equals BC squared. 4 plus 36 equals BC squared. So I get 40. And then when I take the square root, I get the square root of 40. Okay, so the length of BC is the square root of 40. All right, last side length, BD. Up 2 again, over 1, 2, 3, 4, 5, 6. Okay, so it is the same numbers, perfect. So 2 squared plus 6 squared equals BD squared, which when I do the math, I already know I'm going to get the square root of 40. So one of the methods that we use that we learned to use to prove that if triangles are congruent was side, side, side. Finding the side lengths, and if all 3 sides of one triangle are congruent to the corresponding sides of the other triangle, then I'm good to go. I can show the 2 triangles are indeed congruent. And since I'm working on a coordinate plane, that's what I can do. I can find side length. Once again, I don't know anything about my angle, so I can't use that. So the question is asking us, are the corresponding distances the same? And the answer is yes. Let's take a look why. Well, here's the first side of each triangle, AB. What I'm going to do is I'm going to write out ABC. I'm going to show you something. And ABD. Okay, and if you remember, if we're finding corresponding sides, AB and AB, they go in the same order when you're looking at the name of it. Well, of course, they're the same length because it's the same side. So that's good to go. AC and AD. So AC is the first and the last letter, and so is AD. And when I look at my triangle, they're both the same parts. And they are the same length, so that's good. My last corresponding part is BC and BD. Once again, in the same order in the name of the triangle, so they're corresponding, and they are the same lengths. So yes, the corresponding distances are the same. So what does that tell us? Well, it tells us triangle ABC is congruent to triangle ABD by our side, side, side postulate. All right, all three sides were congruent, so we found that the triangle was congruent. Okay, go ahead, pause the video, try number 2 on your own. When you are ready, go ahead, press play, check out what is up here. And if you understand, you can move on to the next example. If not, pause it, take a look, and try to figure out where you went wrong. Pause. Okay, so as I see, the corresponding sides are the same. I found all the measures by drawing my slope steps. If you need help with finding length, make sure you are staying after for extra help, because I'm not going to spend much time reviewing that from here on out. All right, so the corresponding distances are the same. So what does that tell us? Well, it tells us that triangle RIO, okay, once again, naming them in the same order, triangle RIO, is congruent to triangle UGH by our side, side, side theorem. Okay, so finding those sides congruent. All right, let's move on. Taking a look at the next page, looking at example number 3, we're given, once again, 2 triangles, and we're asked to find possible coordinates of F. So if you notice in the second triangle, we aren't given the third point. We need to find it. So let's start by plotting points for triangle A, B, C. So A is at 3, -1. B is at 3, -7, down here. And C is at 6, -1. Okay, so here's my triangle ABC. Sorry for my bad lines. Oh, all right. Okay, now triangle DEF, D is at -5, -1. E is at -5, -7. And we don't know at the moment where F is. So I'm going to go ahead and connect D and E. And we need to find F. Okay, so what are we going to do? Well, we know that we need to talk side length here. And we know we need to keep the order that we are naming our triangles the same way. So the blue triangle, triangle ABC, goes from A down to B over to C. DEF is going to go from D down to E and then over to F. So F can be in 2 different locations. It can be somewhere over here or somewhere over here. All right, but I noticed that in my triangle ABC, A and C are right next to each other. So I need to consider the distance from A to C and then use that to help me find the distance from D to F. Now, it doesn't say that it has to be flipped or facing a certain way, so that's why there's 2 possible locations. So let's take a look. Let's find the distance from A to C first. And once again, the reason we are doing that is because when we talk about our corresponding parts, oops, that's supposed to be DEF, AC corresponds with DF. Okay, so that means I need to use those 2 pieces of information. All right, so to go from A to C, I count over 1, 2, 3. So to find F, I can go 3 to the right, 1, 2, 3, and plot it right here. Or I can go 3 to the left, 1, 2, 3. Both of these are possible locations for F. Okay, so I could draw this triangle, or I could draw this triangle. Let me outline one in red, see the difference, and the other one in black. So there's 2 possible locations. Either one is acceptable, all right, because it doesn't specify where it needs to be. All right, now, for those of you thinkers out there, you also could have found F another way. So looking at triangle ABC, I also know that C, I could have drawn a slope step and figured out the distance from B. From B, I went over 3 and then up 1, 2, 3, 4, 5, 6. So I could have gone from E and then up. So over 3 in either direction, 1, 2, 3, up 1, 2, 3, 4, 5, 6. So either method works. Just make sure you're going in the correct order. Okay, pause the video, try number 4 on your own. Okay, we see that there are once again 2 possibilities for f. All right, I first found the distance from A to C was 2, so I use that over my other triangle from D to F, because once again AC corresponded with DF in this example. So I found that F could be at either -1, 6 or -5, 6. Either answer would be acceptable. And in the last example, we forgot to actually write down the coordinates of our F. So let's go back on your own and please write down those coordinates. Okay, we have one last example to look at. And we're going to talk about, well, what happens now if we are told a specific area to find that missing value in? So it's going to be the same thing we're doing last time, but we're going to limit our possible answer choices. So the problem says, given the following vertices, etc., find the coordinates of f if it is in quadrant 3. So once again, it's just giving us some limitations. So let's start by plotting triangle ABC. A is at 1, 1. B is at 1, 4. C is at 5, 1, and then here's that triangle. All right, now DEF. D is at -1, -1, down here. E is at -1, -4, right here. And we need to find F, okay? So once again, A, B, C, D, E, F. I need to use corresponding parts to help me, so I'm going to look at the location from A to C and then use that to help me find the location from D to F. Once again, you could do B to C and EF, no problem. Okay, multiple possibilities. So let's go back up and talk about this restriction now. It's telling us F has to be in quadrant 3. So if you remember in the last example, there's 2 possible solutions. This is telling us a specific one to find. So quadrant 3, if you remember back to algebra 1, your quadrant, this is quadrant number 1 over here, and that's a Roman numeral number 1, not the letter I. All right, and then we label them going counterclockwise. So this is 2, this is 3, and this is 4. Okay, so the problem says find the F that's in quadrant 3. So I'm looking for the one that's over here. All right, not the other one. All right, so let's think about this. The distance from A to C is 1, 2, 3, 4. So I'm now going from D to F, and be careful. This triangle is flipped. If you notice, A, B, C, the B is on top of the A, but in D, E, F, it's going the other direction. The E is below it. So this is why it's super duper important that you think about the way that the triangles are named. So once again, from A to C is 4, so from D to F is 4. Now if I count 4 to the right, I am no longer in quadrant 3, so it is not asking me for that point. I have to count 4 to the left. And here's F. And there's my triangle. All right, so F in this example was at -1, 2, 3, 4, 5, -1. So difference, giving me a specific location, and the triangle is flipped, so you've got to be careful about that naming. All right, one last time, go ahead, pause that video, try the last example on your own. All right, go ahead, take a look. F is at 3, -1 in this example. Once again, the distance from A to C was 4, so I need a distance of 4 from D to F, and this one specified quadrant 4, which is this quadrant down here. So I moved 4 to the right from D and got that triangle. All right, we are all set for today. Go back, look over your notes, things you're not sure about, make sure you ask about in class.